Right. So before we get into any of the like chapters and content and all of that stuff, I think it's always useful to kind of step back and say, what is this class all about, right? So we're going to get philosophical for a second. I promise this won't happen very often, but every once in a while you got to take a step back and really think about why am I here? Why are we all here in this class, right? And I'm guessing that most of you here aren't in this class because of your passion for general chemistry. That's just not usually a thing that inspires people. Now, some of you might really enjoy chemistry, but probably even those who are into chemistry are thinking about more specific problems, like how do we use chemistry to make pharmaceuticals or new materials or batteries and that kind of thing, right? How do we use chemistry to analyze pollutants in our water and those kinds of things. So, and a lot of that is a more specific discipline of chemistry than general chemistry, which is kind of chemistry in general, right? And so, what general chemistry really is a stepping stone into those other ideas. And so, whether you're here to understand enough chemistry to score well on the MCAT, or whether you're here to understand enough chemistry that you can use that as a career in the future, general chemistry is kind of this fundamental stepping stone course. And so, um, what are we going to learn here, and how is that going to be useful going forward? Um, what we're going to focus on in this class is chemical reactions. We're going to learn what we can about chemical reactions. We're going to do lots of calculations based on chemical reactions. So there's going to be a lot of math. There's going to be a lot of plugging stuff into your calculator, calculating answers, and that kind of thing. But we're going to come at it from the perspective of lots of different areas of chemistry. And so we're going to look at what are the properties of chemical reactions that chemists or people who use chemistry are need to know how to do, right? And basically, it's going to come down to there are three main questions that we're going to try and answer in this course. And so the first one of these is, does this chemical reaction go, right? And so if we mix these chemicals together, do we get a chemical reaction? And the answer to this question is going to depend on entropy and free energy. And so we're going to spend time calculating those things, interpreting those results, and doing all of that kind of thing, right? So does this chemical reaction go? It depends on entropy and free energy. That's the first question, and I guess the first answer of this course. How far does this chemical reaction go, right? Once we get these things reacting, the entropy and free energy allow this reaction to happen. How much product are we going to get out? In order to answer that question, we're going to start to look at equilibrium and look at how do we calculate equilibrium? Once we've calculated that equilibrium data, what does that tell us about the reaction? How do we interpret it? And lastly, is how fast does this chemical reaction go, right? So once we mix the chemical reactions, do we have to wait 20 minutes? Do we have to wait 3 days? Do we have to wait 3 weeks? Right? There are chemical reactions that take all of those lengths of time. How fast does chemical reaction go is really useful information, no matter what area of chemistry or how you're using chemistry, right? And so we're going to look at reaction rates. We're going to calculate a whole bunch of reaction rates. We're going to interpret a whole bunch of reaction rates. We're going to spend some time on this. So there it is. We have three questions. We have three answers. So that's pretty much the course. And all that's left is really the details. The details will take us a while, but this is what we're going to do. How we're going to do this is we're going to look at specific examples of reactions that embody all three of these concepts, right? And so we're going to start. The first one we're going to do is we're going to look at equilibrium and look at acids and bases. Acids and bases use equilibrium all the time. They don't really get into reaction rates or entropy very much. So they're a nice place to start. Right, so we're going to look at acid and base reactions. We're going to apply the concepts of equilibrium to these acid and base reactions in a variety of ways. We're going to look at entropy and free energy through the lens of reduction and oxidation reactions. Right? And so reduction and oxidation reactions use both equilibrium and entropy and free energy in order to kind of decide, does the reaction go? And once it starts going, how far does it go? And then the last thing that we're going to do in this semester is we're going to look at nuclear chemistry through the lens of reaction rate, because nuclear chemistry is just pretty much all reaction rate, right? How fast the nuclear compounds decompose or fall apart or come together is going to be the most important. So really there we have it. This is the introduction. This is what we're going to do this semester. We're going to ask three questions. we're going to investigate the 3 answers to those questions, and we're going to use 3 examples across a variety of chemical reactions, or 3 types of chemical reactions, in order to kind of apply those answers to the stuff that we're doing. So that's where we're going this semester. We're going to start with some solutions chemistry in order to kind of set up the reaction rates and equilibrium stuff that we're going to do, and then we'll move into reactions. So uh, in the next video, we'll define some of these terms, like what is equilibrium, what are reaction rates, what is entropy, and all that kind of stuff. So look for that one next.